f of t equal to square root of t squared plus 3t minus 10. How do you find the domain and range of such a function? Well, first of all, you know that a quantity inside the square root sign cannot be less than 0. It cannot be negative. So to find the domain of this function, we would take the quantity inside the square root and set it greater than or equal to 0. T squared plus 3t minus 10 must be greater than or equal to 0. If this quantity is less than 0, then square root of that quantity will not be meaningful. There will be no output. So the values of t that makes this quantity greater than or equal to 0 are only the domains of this function. Now that's an easy way to find out what are the values of t that will make this quantity a positive quantity. Well, can you draw the graph of this on your calculator? Well, the graph will look like this. And look at the graph. You know that when a part of the graph is below the x-axis, it represents negative output. And the part of the graph above the x-axis represents positive output. Now, we cannot have values of t that will make this quantity negative. That means for all values of t that makes the graph below the x-axis cannot be used in the domain of this function. Do you understand that? You see, for all values of t from this 1, 2, 3, 4, yes, from -5 to 2. This is -5. If you watch here, -1 or -2, -4, -6. But this is -5. If you use any number greater than -5 or less than 2, it will give an output negative. The graph of that is negative. That means for any value of t greater than -5 and less than 2, this quantity will be negative, and the square root of a negative quantity will be undefined. Therefore, these values cannot be in the domain of this function. So an inspection of the graph of t squared plus 3t minus 10 shows that this quantity is negative in this interval, -5, less than t, less than 2. Between -5 and positive 2, this quantity is negative, and therefore these t values are not in the domain of this function. So the domain does not contain values from -5 to 2, and look at the way we write it. The domain is -5, negative infinity to -5, union, 2 to infinity, and look at the brackets we have used here. What does that signify? It means -5 and positive 2 are included in the domain. You have domain values all the way from negative infinity to -5 included are in the domain. And 2 to infinity, 2 included, are in the domain. But greater than -5 and less than 2 are not in the domain. That is what this means. And look at the graph of the function itself. This is the graph of the function. Don't confuse. This is the graph of the quantity inside the square root. And we did that to find out the values of t that will make this quantity negative. And this is the graph of the function square root t squared plus 3t minus 10. If you notice, there are no outputs for t between -5 and positive 2. Output exists only for inputs less than -5 and inputs greater than 2. That's right. Okay, look at the graph and tell me what is the range of this function. Well, the range are all possible outputs. There is no negative output. The minimum output is 0, and you can get any output greater than 0. Therefore, the range will be 0 to infinity, 0 included. So once again, the domain is negative infinity to negative 5, union 2 to infinity. No numbers between negative 5 and 2 are in the domain. And the range can be 0 and anything greater than 0. That is the range of the function. That means looking at the graph of a function, we can determine the domain and range of a function. That's a neat way to determine the domain and range of functions. Alright, what is the domain and range of f of x equal to ln x? Well, you're familiar with the logarithmic function, aren't you? Alright, what is ln of 1? Logarithm of 1 is 0. What is ln of 0.5? If you put in a calculator, you'll see ln of 0.5 is a negative quantity. ln of 0.1 will be a negative quantity. Now, how about ln of 0? ln of 0 is undefined. If you go back and look at how logarithmic functions are defined, you will understand why ln of 0 is undefined. Now look at the graph of f of x equal to ln x. And if you notice, ln of 1 is 0. And as x gets closer and closer to 0 from the left, is that right? This is x equal to 1. As x gets closer and closer to 0 here from the left, the output goes to negative infinity. That's right. That means the domain is only numbers from 0 to infinity, 0 not included, because ln of 0 is undefined. Look at the parenthesis there. And how about the range of this function? You can see the output can be any number from negative infinity to positive infinity. You get all outputs in here. Although inputs are only greater than 0, outputs can be any number. For numbers that are very, very small, close to 0, the output goes to negative infinity. So the range of this function is negative infinity to positive infinity. Let's now look at a similar function, g of x equal to e to the power of x. How does the graph of that look? G of x equal to e to the power of x. Well, that is the graph of e to the power of x. E to the power of 0, when the input is 0, the output is 1. And as the input is less than 0, the output approaches y equal to 0, but you can never get an output of 0 for this function. So the input can be any number from negative infinity to positive infinity. So the domain consists of all real numbers. So we write the domain is negative infinity to positive infinity. Any input can be used in here. E to the power of negative 10 is 1 over e to the power of 10. It's a very small number, close to 0, but not equal to 0. E to the power of negative 1000 is very, very, very close to 0, but not equal to 0. So the domain is negative infinity to positive infinity. The range only contains numbers that are greater than 0. So we will write the range is 0 to infinity, 0 not included. Now if you look at these two functions, you will see something strange or something, well, very interesting. What is that? The domain of the logarithmic function ln x is 0 to infinity. Its range is negative infinity to positive infinity. The domain of the exponential function is negative infinity to positive infinity. its range is 0 to infinity. You see that? The range of the exponential function is the same as the domain of the logarithmic function. The domain of the exponential function is the same as the range of the logarithmic function. What do you call such two functions? Well, you have done that in pre-calculus, I'm sure. They are inverse of each other. So f of x equal to ln x and g of x equal to e to the power of x are inverse of each other. The domain of one function is the range of the other, and the range of one is the domain of the other. And also, if you now take this graph and keep it in here, you will see the graph of one is the reflection of the graph of the other along the line y equal to x. All these things discussed in your college algebra and pre-calculus class. We will now look at the meaning of